At this phase of the setup, we have to assign physical steering wheel to application. So we go to Setup, then Virtual Controller, then Virtual Joystick Access Setup. Then click on Axis A. Now select the game controller that you have connected. Then select the axis where the steering wheel was assigned to by default. Now you can move the steering wheel left and right and see if the input value for the axis A is also moving. If that is alright, close the window and click on Setup, then Game Control Function Setup. Now click Controls, then Electric Car, as in our case. Then click Steering Wheel. Now we have to assign a physical steering wheel to the steering wheel in the application. So we are going to click on Axis A. Now we have to assign the steering wheel with the servo output. So we are going to select the Servo A. These terminals shown in the video are designed to power the servos, and there is a smaller bank of the terminals and it is powered by the ESC. Since the ESC is still not connected from the safety reasons, we are going to use the larger bank of terminals to power our steering servo. We are going to connect our steering servo to servo output A. Now you should be able to steer the wheels and their movement will be restricted, but we will tune that in tutorial number 4. The movement of the steering wheel and the servo are also going to be animated in the application. If the wheels are steering into opposite direction from the steering wheel, you have to go to Setup, then Model Control, then Servo Motor PWM output, then click to Servo Out A, then click Invert Servo Movement. At this phase of the setup, we are ready to install the link shock sensor, but before that we are going to disassign the servo by clicking at Not Selected. That way we will not be able to steer the servo anymore, but it is going to maintain its original position during the installation process. Remove the original link and make sure that your servo saver is completely loosened so the steering mechanism does not have any mechanical resistance and it's free to move. The length of the sensor can be adjusted from 28 to 51 mm without requiring additional modifications. When extending the sensor, ensure that linkages engage at least 2/3 of the thread to prevent them from coming apart. Use the original linkage to adjust the sensor length. A helpful tip is to align the linkages using 3M screws to ensure that they are set to equal lengths. After the sensor was installed, we are ready to connect it at analog input section. Make sure that the negative side of the connector is turned toward inner side of the terminals. Connect the sensor to analog input A. Once the sensor is connected, you will be able to see the force level reading at the model monitoring panel. And now we have to assign it to our steering wheel by clicking Setup, then Game Control Functions, then Force Feedback, Car, Force Feedback Steering Wheel. And now we have to select Analog Input A, And here we have to select at which axis we want our force feedback to be generated to. So this is usually the axis X by default. Now we can apply gentle force at the wheels and see if the force is transferred to the steering wheel. The wheel and also the sensor are going to be animated in the application. We have to apply some force and see if the force is transferred into proper direction. If the force has inverted direction as here shown in the video, we have to invert the force by clicking Setup, Model Control, Analog ADC Inputs, and then Invert ADC A. Since in our case the force has proper direction, we will uncheck it. Now we are ready to assign the servo back to Servo A. We can finally both steer the wheels and feel the force feedback at the steering wheel. Since the sensor has some small internal imperfections, it might generate a consistent force in one direction at the steering wheel. It can be eliminated by fine-tuning the Trim X slider on the force feedback panel. Once that is finished, we are ready for fourth tutorial where we are going to adjust the endpoints.